So last class we had seen the graphs of all the trigonometric function, and then we saw how to make them bijective in what interval. And today what we will do, we'll not make that graph every time. So we'll make our summary first, then talk about angle inversions, which will be very important to solve problems in this chapter. Then we will go for problems. Okay. So let's talk about our trigonometric functions and their inverse. Metric functions and their inverse, and we'll talk about the domain and range. Okay, now how to remember and how to do it, because every time you won't be able to draw a graph. Domain, range, right? And let this be our function. Even you can also do this. There is no rocket science. Just see, the first function that we talk about is the sine function. Sine function, right? Sine function. Now children, we will be talking about principal domain. In sine function we can enter anything. Just remember, in sine function we can enter anything, but the domain of the sine function for this will always be restricted from negative pi by 2 to pi by 2. And just start visualizing. Sine has to be bijective, so it's from negative pi by 2, and the range will always be -1 and +1. This you have to remember. This is not that difficult. Okay, now if that be the case, then sine inverse. Acha, try to understand what have you done here. This is not the general domain of sine function. The general domain of sine function is real numbers. This is the domain in which sine is bijective. So when we see sine inverse, we will just swap these two. So it will take -1 +1, and its range will be negative pi by 2 to pi by 2. Okay. My second function is cos function. Cos. In cos, my principal domain will be 0 and pi. The range will be -1 +1. So cos inverse will be -1 +1, and the principal range of the inverse function will be 0, pi. Remember one thing, this is the principal range of the inverse function, whereas this is the principal domain of the proper function. Is this clear? Okay. Take your time. Next function is tan function. Now remember, tan cannot take any 90, 270. Tan is not defined for that. So our tan, the way to remember, if you don't remember the graph also, tan is just like sine, but with these two not included. So tan would be a negative pi by 2 to a pi by 2, and the range will be all real numbers. Similarly, a tan inverse would be from R. A tan inverse will be from R, and it will be negative pi by 2 and pi by 2. Tan function cannot take pi by 2 and negative pi by 2, but will cross over from 0. Fine. If we have done tan, let's do cot immediately. Cot function. Cot will be just like cos. 0 and a pi, but not included. So here it will be, a cot function can take all real numbers. So cot inverse will take real numbers 0 and pi. set 3, set 4, set 5, cosec function. Now, if you see the cosec function will not be able to take those values in which sine becomes 0. That means cosec cannot take the value of pi. Cosec cannot take the value, so it will be cosec will be from a negative pi by 2 to a pi by 2, right? And which one? Yeah, this will be included because it will be pi. Sorry, and will not take 0. 1 minute. Huh? Sorry. This was for sec actually. Okay. A cosec will take negative pi by 2. See, you're seeing sine from pi by 2 to minus pi by 2 to pi by 2. So cosec will be the same. Negative pi by 2 to pi by 2, but cannot take 0, and will give you all real numbers minus negative 1 and 1. So cosec inverse would be all real numbers minus negative 1, 1, and my sixth one would be sec function. Sec will be taking the 0 and pi, however cannot take a pi by 2 in between, and will be all real numbers 1. Sec inverse would be all real numbers 1, and that's it. Not so difficult. Okay. Now, before proceeding ahead with problems, what we will do, a couple of problems. What we will do, we'll first see the inversions so that you are fine with your inversions, and then only we will do some problems. Let's first see inversions. Angle inversions. Can I change? Okay. Now this one, pay attention, and it's very easy if you remember it this way. For this, first don't write anything. Just listen to the story, then it will become easy. Angles are measured always in anti-clockwise manner, right? So I start with a 0 degree, then I go to a 90 degree, which is also a pi upon 2. I go to 180 degree, which is a pi. I come to 270 degree, which is a 3 pi by 2. So these are all pi by 2, pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, which is 360 degree, can also be written as 2 pi. Agreed? Then again, this is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. Right? Now, some desi names you have to remember. This is known as, this is sleeping line. Sleeping line is a lazy line. Remember like that. Lazy line cannot bring, a lazy person cannot bring change in society. Cannot bring change in society. Society for your case would be function. This is a sleeping line. A sleeping line is a lazy line. Lazy line cannot bring any change in society. Correct? And this line is standing line. Standing line is like a Bahubali line. Can bring change in society. Society means, in your language, function, right? Whenever you will do angle inversions, whenever you do angle inversions, there are two things you will do. Whenever you add or subtract angles from pi or pi by 2 or their multiples, right? Two things happen. One is function inversion, and the second is sign change. Whenever you would be adding or subtracting angles to, suppose, a pi by 2 or a 3 pi by 2 or a 4 pi by 2, 5 pi, whatever it is, there will be a function inversion and a sign change. Let's first understand about function inversions. The function inversions will follow a chronology. If you have sine, it will invert to cos, and vice versa. Tan inverts with cot, and here they are reciprocals. Cosec and sec invert with each other. Clear? समझ में आया? अब कुछ नहीं, अब just formula लगाना है हमें. Story is set, stage is set. All we need to now do is just set the formula. ठीक है? So let's set our formula. I'm going with a basic thing, right? My first example would be sine pi plus theta. Sine pi plus theta. Now stop writing. If you have written everything, you write everything, then I'll teach this part. Sine pi plus theta. Ready? So see, pi, 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. That means pi always lies on slipping line. Anything with pi is always on slipping line. Slipping line is a lazy line. Can it change the function? No, it cannot change the function. So if you are on slipping line, we will straight away write sine theta. Function does not change. Agreed? First thing. Then we have to see, this is the first part. We have addressed only the first part. Function inversion? No inversion. Then comes the sine. Sine of pi, pi means here, plus theta. Where are you falling? Third quadrant. You know this? So this is your quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. And as we say, all sine, tan, cos, add sugar to coffee, after school to college, whatever you want. All sine, tan, cos. Achha. Where did you land up now? You landed up in third quadrant. In third quadrant, only tan can be positive. Now, when I say only tan, original function. Was your original function tan? No, your original function was sine. So you don't have the authority to be positive. You will be a minus sine theta. Have you understood? Okay. Now wait. Just wait. Let us see the beauty now. You landed here, right? Let's land here with another example. This is example 1. Let's see another example 2. Say I have sine 3 pi by 2 minus theta. 3 pi by 2 minus theta. 3 pi by 2 is here, minus theta. Still I'll be here. 3 pi by 2. Pi by 2 lands on standing line. Does standing line change functions? Yes. Standing lines change function. Now this is 3 pi by 2 minus theta. Okay. Now your theta is actually this side. This side is your theta. See how to. Okay, let me make it easy for you. 1 minute. Let's say earlier you had this as theta. Now I am taking this as alpha. So that we are at the same angle, right? And allow me to write this as minus alpha. 3 pi by 2 minus alpha. So you'll be at the same position, right? So 3 pi by 2. Now, pi by 2 is a standing line. Standing line can invert a function. So your function inverts now to what, beta? Cos. Cos of what? Alpha. Whatever is this value, cos of alpha. But you landed on which? Quadrant 3. Now in quadrant 3, who can be positive? Tan can be positive. Your original function was sine. So sine is not allowed to be positive. So it remains as negative cos alpha. Now alpha and theta are complementary angles. Whatever will be alpha's value will also be theta's value. So from here, okay, just from here, can I write it as negative of cos of 90 minus theta? 90 minus theta is alpha, right? 90 minus theta is alpha. Now let's go further. Retain the negative. Cos of 90 minus theta. 90 is a standing line. 90s can invert the function. Sine theta. Right? But you are landing on which one? Which you're still 90 minus theta. And 90 minus theta, negative of 90 minus theta. Now you are 90 means you are on first quadrant. All are positive. So we retain this value, minus 9 sine theta. So ultimately this is coming to minus sine theta. I just tried to show you that whether you do by 90 or all. Shall we take some cases now? Okay, let's take some cases. Let's say somebody tells you, find the value of tan pi minus theta. Somebody tells you tan pi minus theta. Tell me, Neha, how will you go? Tan pi. First locate pi. Pi is on sleeping line. Sleeping lines are all lazy people. They cannot change the function. Tan theta. Tan pi minus theta means you will be on second quadrant. Here only sign can be positive. Your parent function is negative. अब इसको लेके आप कुछ भी कर सकते हैं. Shall we try some more? Okay, can you tell me what is the value of cosec 7 pi by 2 plus theta? Cosec 7 pi by 2. Don't forget that 7. Pi by 2. Pi by 2 means standing line. Standing line means they can bring change in society. Cosec will change to sec and theta. Now look at 7 pi by 2. Look, pi by 2, 3 pi by 2. 5 pi by 2, 7 pi by 2. 7 pi by 2 plus theta. Fourth quadrant. Fourth quadrant means all sine, tan, cos. Only cos can be positive. Your parent function was cosec. You don't have the authority to be positive. Minus sec theta. Okay, let's solve. Sine 9 pi minus theta. Sine 9 pi minus theta. First forget the 9. Pi means sleeping line. Lazy fellow. You can't do anything in your life. Sine theta. 9 pi. Look here. 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. 9 pi minus theta. Quadrant 2. Only sine is allowed to be positive. Parent function was sine. So I retain my value as plus sine theta. Cot 5 pi by 2 minus theta. Pi by 2 means cot will change to tan. 5 pi by 2. 1 pi by 2, 3 pi by 2, 5 pi by 2 minus theta. So first quadrant. First quadrant everybody is positive. So it is plus tan theta. Have you grasped it? Do you think you need to remember it now? No. It is very easy.
So for example, this
Give me one example. We will do it. Bolo na.
like if cot falls in the third quadrant.
If cot falls in the third quadrant, so let's make cot in the third quadrant. Cot of pi plus theta. Let's say 3 pi plus theta. Okay?
So cot is 1 by tan. So according to that, the parent function will be tan.
Let's go by this. Cot 3 pi plus theta. Agreed? I'll address your query. Cot 3 pi plus theta means, first of all, pi plus theta. Pi plus theta, does the function change ever? No. So the function will remain as cot theta. 3 pi is always on this side. This side is always even pi's, odd pi's. 3 pi plus theta, that means on third quadrant. All sine tan. Tan is allowed to be positive. Is the parent function tan? No, the parent function is cot. So this will become negative. Is it? No, it will be positive.
Yeah,
because tan is positive. So for sec, cosec, and this, you have to take the criteria. So see whether we were correct on this one.
No, that will be
See this one. There is a, sorry, Sarthak, thank you. So 7 pi by 2. Pi by 2 plus theta. Pi by 2 plus theta means, obviously, our issue was on this one, right? So our issue was on this. Let's check it. Cosec will change to sec. It will become sec theta. 7 pi, 1 pi, 3 pi, 5 pi, 7 pi. 7 pi plus theta. 7 pi plus theta means you will be on fourth quadrant. On fourth quadrant, all sine, tan, cos is allowed to be positive. But your parent function is cosec, which is reciprocal of sine. So this will be negative, no doubt about it. This will be negative. Okay, let's check anyone at the back side whether we were right. Did we take any sec? We have not taken any sec so far. Let's take one sec. Okay, let's say we have sec 6 pi minus theta. Sec 6 pi minus theta. 6 pi means you are a slipping line. So function remains as sec theta. The function remains as sec theta. And 6 pi means it is always the zero line. 6 pi minus theta means you are on fourth quadrant. Fourth quadrant, parent function cos is positive, so sec is also positive. So we retain our answer as percent. Clear now? अच्छा, आप कुछ देखते हैं, something called even functions and odd functions. Even functions and odd functions. So like sine is even, cos is odd. So it goes like this. A sine of negative theta is negative sine theta. Okay. A tan of negative theta is negative tan theta. A cos of negative theta, now this is odd function, would be a cos theta. Okay. Only cos and sec. Okay. A sec of negative theta is a sec theta. A cot of negative theta is a negative cot theta. A cosec of negative theta is a negative cosec theta. You need not break your head on this one also. See, if you anytime have a problem in any exam and you got stuck up, right? Understood? So let's take a negative theta out here. Let's take a negative theta out here. This is negative theta. Theta measured on this side would be negative theta. Now this is negative theta. Agreed? Okay. And what I do here is that now children, this measurement is a positive A because this is positive A. However, this is a negative B because this much is negative B. Do you agree? And the hypotenuse is something called R, which is a root under A square plus a negative b square, which means my hypotenuse is always positive. Hypotenuse is always positive, which is say root under a square plus b square, means it is positive. Here the hypotenuse is always positive. Now you yourself take sine of minus theta, opposite side negative b by hypotenuse r, so it will always be negative. Understood? If sine is negative, then cosec of negative theta will also be negative. Okay? Let's look about cos of negative theta. Cos of negative theta is what, beta? Adjacent side, a positive a over a positive r, which is positive. So a sec of negative theta should also be positive. Tan negative theta is equal to opposite side negative b over adjacent side a, which is negative. That means cot of negative theta should also be negative. I think we're done with all. 1, 2, 3, 4, 5, 6. Yeah. So remember, in calculus and everywhere, trigonometry, cos is a very bad boy. Just remember like that. Cos is a bad boy. Cos will always make everything garbad. ddx of cos x minus sin x. So cos is always bad boy. Cos c plus cos d minus 2 sin c plus d. If you see all cos formulas, they will make all positives as negatives. These two things are clear. Maybe in grade 11 this was, you used to mug it up, but there is no need of mugging it up. If you learn it this way, job becomes much more easy. That's so much easy. R is always positive. Done. Shall we go back to now inverse trigonometric? Okay, slowly we will enter into inverse trigonometric. So I believe, because function transformations will be one of the basic thing that will be required in this particular chapter. Otherwise, you will not be able to do. Shall we? Okay, now understand one thing. I always used to tell you that a function and its inverse is like COVID and Covaxin. So let's take one example. Let's say I write, what is sine of sine inverse x? And you will say that this is x. So many days you used to say like this. Here the parent function is trigonometric function. The parent function is trigonometric function. Are you getting it? Now in this case, for this function to be valid, what is this function's domain? The function's domain, this thing should be valid. Sine inverse x, this should be valid first. If this function, this input is not valid, automatically this function is not valid. So for this function to be valid, that is sine inverse x, what should be the domain of sine inverse x? What do you enter inside sine inverse x? Yes, we will write this value is equal to x if and only if x is such that it is greater than equal to -1, less than equal to +1, or x belongs to the family -1 to +1. This is to be treated as a simple trigonometric function. This is a sine of blah blah. Blah blah is the domain. A domain is a possible input. That means the domain is an inverse function. The inverse function should be possible. For the inverse function to be possible, x should take the value this. So sine of this anything x is equal to this is valid only when. However, if you change this function and make it like this now, sine inverse sine x is equal to x. You don't have the right to write it like this, though you feel that this is Covaxin, this is COVID, so it will be the person. No, this is an inverse function. Inverse function's domain has to be valid. Means sine x has to be valid. Sine x has to be valid for sine inverse to exist. Overall sine inverse must be valid. So here what will happen for sine x, we will say this is x if and only if x belongs to negative pi by 2 and pi by 2. Just check. Because in no other input will you get sine inverse as bijective. And sine inverse of sine inverse, you're getting a value. You're getting a value. X is what? The range. This is a value. And the range can always be, what is the principal range of a sine function? The principal range of a sine function is always minus pi by 2. Sine means sine inverse function is minus pi by 2. See, there are many ways to understand this. Forget this sign. Just look at the parent function. It's an inverse function. It has to throw an output. So what is the output? What is the output? The output is the range. The range is what? The principal range. Is this clear? So based on this, let's take up a problem which is say sine inverse sine 3 pi by 2. Sine inverse sine 3 pi by 2. We are supposed to solve this problem. Now what you will do? You feel this is covaxin, this is COVID, and you will give the answer as 3 pi by 2. But can a sine inverse function give a 3 pi by 2? No. Why? We will write 3 pi by 2 does not belong to negative pi by 2 pi by 2. Acha, how to check this? If you are having any doubt, this range is minus 90 to plus 90. 3 pi, 3 into 180, 540. 18354. 540 divided by 2 is how much? 220. So it is beyond this range. ये तो नहीं होगा. 270. This is beyond. This is not working. So we have to transform 3 pi by 2 to have it in minus pi by 2 to pi by 2. We have to transform 3 pi by 2. Right. So let's see. So we can now write this as sine inverse sine 3 pi by 2. So let's take it as sine of pi minus 3 pi by 2. Just check this. Check this once. Sine of pi minus 3 pi by 2. The function should be what? See, this value and this value cannot change. So sine pi means sleeping line. So it will be sine 3 pi by 2. Right? And parent function is sine.
Yeah.
And pi minus means second quadrant. So it remains positive as 3 pi by 2. Are you understanding what I'm trying to say? See, the children initially get confused. I am just trying to transform this 3 pi by 2 as this. Now you will say, sir, if I solve this, this is not 3 pi by 2. Oh my child, I am not trying to solve. I look at the transformation possibility. So now what I do, I write it as sine inverse, and here I will now make it sine of 2 pi minus 3 pi upon 2. Can I do this? Which gives me sine inverse sine of negative pi by 2. Arey, my job is done. See, when such problems come, now this has to be between negative pi by 2 to pi by 2. So I just solved it. It's negative pi by 2. Now I have the authority to write it as negative pi by 2, as negative pi by 2 belongs to negative pi by 2 pi by 2, which is the principal range of sine function, sine inverse. That is the PR, principal range of sine inverse function. So all the job is all about transformation, transformation, transformation. One more problem. Cos inverse cos of 5 pi by 4. Cos inverse cos of 5 pi by 4. Yeah. Cos inverse cos of 5 pi by 4. Now, look at this problem. First of all, for a cos function, your value should be between 0 and pi, which means 0 to 180 degree. 5 pi, 5 into 180 divided by 4. So anyway, it is crossing pi. 5 divided by 4 is more than 1 pi. So 5 pi by 4 does not belong to 0 pi. So we have to transform 5 pi by 4. Now, how will you transform? Pi plus, so let's make it like this, all sine 10. Okay, so let's make it like this. Let's see, always it will be with pi only, don't worry. So let's make it cos of pi plus 5 pi by 4. Just see. Do this step and don't proceed further. Check yourself. Check. Pi plus 5 pi by 4. Pi plus 5 pi by 4 means it is still cos pi by 4. Right? But pi plus means you are on the third quadrant. If you are on the third quadrant, then your function will become negative. Your function becomes negative. Right? And if I solve this up, how much this will be? 4 plus pi plus 5 pi. So can we then make it pi minus? This will not work. So let's make it pi minus 5 pi by 4. Right? Pi minus means you will get into second quadrant. So there you will be, it will be only sine is positive, cos is negative. But that negative we will deal. Just let's see the first thing. It becomes how much? Negative pi by 4. Negative pi by 4 means 0 to negative pi by 4. This will be how much? 4 pi minus 5 pi. 4 pi minus 5 pi will make it how much? Negative?
Yeah.
No. First check whether this function is making your job or not. Pi minus 4 pi by 4. So it will be cos of negative pi by 4. Cos of negative pi by 4 is cos of pi by 4. But is this same as this? For me, yes. What is the big deal? Cos pi minus 5 by 4. Is it cos 5 pi by 4? Cos of pi minus theta. Just see, what is cos of pi minus theta? Is it all sine minus cos theta? So minus cos theta. So can I put a negative out here?
So if we add pi plus pi by 4, it should land in fourth quadrant.
Pi plus 5 pi by 4. That's what I'm saying. This iteration you have to work out. If you add, let's say you make it cos of, right? This is cos inverse. It will easily come in. Just wait for 1 or 2 problems. Cos inverse pi plus 5 pi by 4. All right. Cos of pi plus 5 pi by 4. Very nice observation. 5 pi by 4 means pi by 4, 3 pi by 4. 5 pi by 4.
Oh,
Pi by 4.
I will get out.
This is pi by 4. That is pi by 2. Yeah. Pi plus pi by 4. Pi plus pi by 4 means where will you land up with? 9 pi by 4. 9 pi by 4. But 9 pi by 4, what is the value of 9 pi by 4? It is much more than pi times. So your job won't be done. Your value has to be between. Socho, think. How will you transform this? 5 pi by 4 means you have overshot pi by 4. 5 pi by 4. Cos inverse, can we write it like this now? Cos inverse cos of pi plus pi by 4. Let's keep it like this. Pi plus pi by 4 is how much? 4 pi plus pi is 5 pi by 4. So our step is same, right? Now transform this function. Let's transform this function. This will be cos inverse, right? What will you get here? Pi plus. Pi means function does not change. So it still remains cos of pi by 4. But the quadrant will be what? Pi plus. That means third quadrant. Pi by 2, pi plus. Third quadrant. In third quadrant, all sine tan is positive. So this function becomes negative. Now we have to massage the negative pi by 4. One step done. So we are now landed up to cos inverse negative cos of pi by 4. You still can't cancel. You still can't cancel. Now the negative has to be taken off. Now it is easy. एक दो प्रॉब्लम करने के बाद automatically it will come up. Cos of pi minus pi by 4. Just check this. Pi minus pi by 4. Forget this negative. Cos of pi minus pi by 4 will be a cos of pi by 4, right? However, what is the function transformation? Pi minus. So in second quadrant, only sign is allowed to be positive. So you will remain as negative. So it becomes cos inverse. This is the minus that you had. This function will transform to cos pi by 4. And cos pi by 4 will be negative. So a negative of negative will make it positive. And finally you get the answer as pi by 4, and pi by 4 belongs to 0 pi. So your answer is valid now. Actually, in your exercise problems also, you should do some what you call negative problems. We'll do those negative problems where these graph problems are easy. As some negative problems also. Yeah, these will be more interesting. Chalo, let's do some problems. These are your exercise problems, okay? In your first exercise, you'll be asked to find principal values. Principal values. And the problems are like these here. Okay, first one. Find the principal value of sine inverse negative half. Find the principal value of sine inverse negative half. Okay, how to solve this? Just see, children. Acha, few things you should know. Just look at here. 0, 30 degree, 45 degree, 60 degree, 90 degree. This is pi by 2, pi by 3, pi by 4, pi by 6, 0. Okay. Now half. Get me a value of sine which is half. Sine 30 is half. You remember? Sine 30 is half. So can I write this as sine inverse negative sine 30, which means sine pi by 6? Am I allowed to write this? Which means you just learned that sine is an even function. I can write this as sine of negative pi by 6. And now you have the authority to write it as negative pi by 6, as negative pi by 6 belongs to negative pi by 2 and positive pi by 2. Why did I write this? It's an inverse function. And for inverse function, I should know the inverse principal range, and this is the principal value of the function of this problem. Acha, children, sine inverse negative half, calculator may give you many values, but the principal value is only this, because only in this range the function's inverse exists. Can you solve this problem? The next one. This is an easy one. Cos inverse root 3 by 2. Cos 30. Cos inverse cos of pi by 6. And you can straight away write pi by 6. Acha, did you understand how quickly you are able to write this pi by 6 belongs? Pi by 6 is a 30. Your principal range is from negative 90 to positive 90. And this is how much? This is only a 30. 0 to pi. So, 0 to pi. I should write, 0 to pi. 0 to pi. 0 to pi means up to 180 you can go. Okay. Can you do its negative? Try. Give a try. You should always try the negatives. Cos is odd function. Cos is a bad boy. Cos of negative theta is cos theta. Do the negative. And it will be very easy. Whenever it is negative, everything can be solved with a pi relation. So let's write it. This is cos inverse cos of negative cos of pi by 6. Agreed? Negative cos of pi by 6. Now, children, if I write cos of pi minus pi by 6, just see, pi minus pi by 6. Forget everything. Pi minus pi by 6. Pi is a sleeping line. So my function will be cos pi by 6, no issues. Pi minus means I'm in second quadrant. Who is positive in second quadrant? Sine, but this is a cos function. So this is this, which means if this is blah blah, this is also blah blah. So I can replace it with latla. Cos inverse cos of pi minus pi by 6. Now solve this. It becomes cos inverse cos of how much? 6 pi minus pi? 5 pi by 6. Children, a 5 pi by 6 is always less than a pi. Alright? So I can write this as 5 pi by 6 as 5 pi by 6 belongs to 0 pi. Is it getting a little bit easy now? एक और करें. Do cosec inverse 2. Do you want me to keep the screen? Okay. Another question. Do cosec inverse 2. 2 means sine 30 is half. So reciprocal of sine 30 is cosec. So what do I write here? I will write cosec inverse cosec pi by 6. Agreed? Now what is the principle for cosec? Cosec is always, no, don't rotate. Cosec is just like sine. Tell me what is sine?
minus pi by 2 pi by 2.
Minus pi by 2 to pi by 2. So here also it will be minus pi by 2 pi by 2, but cannot take the 0. And you are at pi by 6. Dil khol ke jayega ye. Cosec is same as sine. If you remember sine cos, you can actually find everyone. So this is pi by 6, as pi by 6 belongs to the interval negative pi by 2, positive pi by 2, minus 0. ये तो कोसेक था. अच्छा, सेक में क्या होगा? 0 and pi by 2 will be eliminated. 0 pi by 2 eliminated. Here it will be this. Cosec. अच्छा, can you solve it for cosec inverse negative 2? Negatives हमेशा solve करो. Positive is not the issue. The negatives will make you cry. Negative. This will be equal to cosec inverse negative cosec pi by 6. Agreed? Okay. Which is equal to, now this is an even function. Even function may no tension. Cosec negative pi by 6. And this can be straight away written as negative pi by 6 as negative pi by 6 belongs to negative pi by 2 minus 0. ठीक है? Some more. Even functions are easy. The problem will be only with cos and sec. And what is the formula for cos and sec? Pi minus pi minus. Pi minus pi minus. Okay, let's solve tan inverse negative 1 by root 3. Tan inverse negative 1 by root 3. Now tan 1 by root 3 is tan 30. Tan 60 is root 3. Tan 30 is 1 by root 3. Shall we go? This will be tan of tan inverse tan of minus pi by 6. ठीक है बच्चा? So this is tan inverse tan negative pi by 6. Now what is tan? Tan follows sine except that it is with open intervals. Sine kai. So can we write it as negative pi by 6 as negative pi by 6 belongs to negative pi by 2 pi by 2. Tan is same as sine, just with the curve brackets. Tan is same as sine, just with the curve bracket. Okay, bachcha log, you solve. Tan of negative root 3. Tan 60 is root 3. Pi by 3. So Greek Latin? Oh yes, everything is inverse. Principal values. So this becomes tan inverse negative tan pi by 3. 60 means pi by 3. Lesser denominator, greater value. So this becomes tan inverse. I can write it as tan of negative pi by 3. So see, life becomes so easy. Now you have understood. Pi by 3. Pi by 3 is any day smaller than pi by 2. So it will be always inside that tan wala chakkar. So it goes as negative pi by 3 as negative pi by 3 belongs to the interval what? For, we are doing for tan. So for tan it will be negative pi by 2, positive pi by 2, but with circular brackets or curve brackets. Right, bacha? Okay. Cos inverse minus half. Cos inverse minus half. Acha, be very careful. Huh? Now you're getting on cos. Cos is a bad boy. Cos means odd function. So we will play it with pi. We'll play it with pi. Acha, chal. Karte hain isko. So this becomes how much? Cos inverse cos of 60 So minus pi by 3. Agreed? Now pi by 3 means straight away use the pi formula. Look here. Negative cos pi by 3. You can straight write it as cos of pi minus pi by 3. So what do you get? You get a cos pi by 3. Since you are landing upon second quadrant, negative. So you can write this value. Okay. So this becomes cos inverse cos pi minus pi by 3. Cos inverse, this is 3 pi minus pi is 2 pi. Cos 2 pi by 3. Children, a 2 pi by 3 is any day lesser than, right. Clear? Sec inverse 2 by root 3. So this is root 3 by 2. Cos 30 is root 3 by 2. So this will be sec inverse sec of how much? Pi by 6. Achha, sec will be following what? Sec will be following the same thing that sine follows. So it will be 0 to pi, sorry, cos 0 to pi minus pi by 2. So we will write, can we write it straight away as pi by 6? Obviously, as pi by 6 belongs to 0 pi minus pi by 2 as a value. See, now you need not remember, the ranges will come very easily to you. It had it tan sec. Okay, this is cos sec. Had it been cot, then it would have been curve bracket. Okay? Yeah. So let's do the negative of this. Acha, sec is the wife of cos. ये भी बदमाश बच्चा है. Right? Remember that. Sec inverse negative 2 upon root 3. So we will write this as sec inverse sec minus pi by 6. Agreed? So we can write it as sec inverse. Now see, minus sec pi by 6, and you write sec pi minus pi by 6. Sec pi minus pi by 6 is always sec pi by 6 since you go into second quadrant, so negative. So you can punch that value straight away. So it means sec pi minus pi by 6. Okay, bacha? So this becomes sec inverse sec of how much? 6 pi minus pi? 5 pi by 6. Children, a 5 pi by 6 is always less than pi. So I can write it as 5 pi by 6, as 5 pi by 6 belongs to 0 pi minus pi by 2. 0 pi minus pi by 2. ठीक है? Then some more. बाकी आप कर पाओगे. Let's do this type of problem before we close. Okay. Now this is a long problem which is combination of 3 problems. Okay. Tan inverse 1 plus cos inverse. Achha, wherever there is cos, it is a little bit troublesome for you. Okay. Cos inverse negative half plus sine inverse negative half. Sine and tan will not be issue for us. Tan 45 is 1, right children? So we write tan inverse tan pi by 4, very good, plus cos inverse cos negative cos 60 pi by 3, and then plus sine inverse sine of pi by This is negative. Sine pi by 6. Sine 30 is half. So tan inverse tan pi by 4. We can write it pi by 4 straight away. Tan takes the value, will always be in curved bracket of sine. So this is valid, right? And cos को थोड़ा सा massage करना पड़ेगा. So we'll take cos minus 1 and we'll write as cos of pi minus pi by 3, right? And sine, what we will do, sine we will straight away put it in the bracket because sine is a even function. So this value is a pi by 4, right? This value will be a cos inverse 3 pi minus pi. So this is a very good cos of 2 pi by 3, and this becomes this we can straight away release minus pi by 6. So we get a pi by 4. We add how much? 2 pi by 3. 2 pi by 3 is any day less than pi? Yes. And minus pi by 6. So 3 and 6, the LCM will always be 6. So this is 2, 4 pi minus pi, right? So this is 3 pi. So pi by 4 plus 3 pi by 6, which is actually pi by 2. So here the LCM is again 4 pi plus 2 pi. So it becomes 3 pi by 4. Can you try now 2.1 problems? And then we'll see the next. Easy onboarding. You have done this in school, right? Already? Was what? Hebrew, Latin. Transformation. You used to mug up all those values and then you will be shuffling why this, why that. Now you see everything like the cosec curve. You should know how cosec curves up, down, touches the 1 point, doesn't touch the pi's. The secs won't touch the pi by 2's. The tans won't touch the pi by 2's. The cots won't touch the pi's. So it becomes so easy. Yes. So we